The Amprobe DGC-1000 is a digital ground loop tester capable of measuring ground resistance, ground current, and voltage. It is generally suitable for testing ground rods in many applications. However, it is important to consider its limitations. Firstly, sensitivity. The DGC-1000 has a sensitivity of 0.1 ohms, which may not be sufficient for highly sensitive applications or for testing very low resistance ground rods. Secondly, test current. The DGC-1000 uses a test current of up to 100 milliamps. This may be too high for testing sensitive electronic equipment or for locations where stray currents could interfere with the test. To ensure accurate and reliable ground rod testing using the Amprobe DGC-1000, follow these steps. 1. Disconnect the ground rod. Disconnect all grounding conductors from the ground rod being tested. 2. Set up test leads. Connect the black lead to the ground rod and the red lead to a known good ground reference point. 3. Turn on the tester. Power on the DGC-1000 and select the ground resistance mode. 4. Initiate the test. Press the test button to start the measurement. 5. Read the results. The display will show the measured ground resistance in ohms. In addition to the DGC-1000, there are other methods and instruments available for ground rod testing. One alternative is the fall of potential method. This method uses a high current source and multiple probes to measure ground potential gradients. It provides more accurate results but requires specialized equipment and expertise. Another alternative are clamp-on ground testers. These testers can measure ground current without disconnecting the ground rod. They are convenient and easy to use but may not be as accurate as other methods. For most applications, the Amprobe DGC-1000 is a suitable ground rod tester. However, for highly sensitive applications or for testing very low resistance ground rods, consider using additional testing methods or instruments as needed. Understanding ground resistance is vital for electrical safety and proper equipment function. Ground rods provide a path for fault current to safely dissipate into the earth, protecting people and equipment from electrical shock and damage. Regular testing ensures the grounding system remains effective. When selecting a ground rod tester, consider the specific requirements of your application, including the sensitivity needed, the potential for stray currents, and the desired level of accuracy. The Amprobe DGC-1000 is a convenient and versatile tool, but it's crucial to be aware of its limitations and to use it correctly. Disconnecting the ground rod during testing is essential to isolate the ground rod's resistance from other parallel paths in the grounding system, providing an accurate measurement. Using a known good ground reference point for the red test lead ensures that the measurement is referenced to a stable and reliable ground potential. The ground resistance mode on the DGC-1000 is specifically designed for measuring the resistance of the ground rod to earth. Pressing the test button initiates the measurement process, sending a test current through the ground rod and measuring the resulting voltage drop to calculate resistance. The display shows the measured ground resistance in ohms, which should be compared to acceptable limits based on relevant standards and regulations. If the measured ground resistance is too high, it indicates a problem with the ground rod or its connection to earth, requiring further investigation and corrective action. The fall of potential method, while more complex, offers a more comprehensive assessment of the grounding system's performance by measuring the ground potential gradients around the ground rod. Clamp-on ground testers are particularly useful in situations where disconnecting the ground rod is not feasible or practical, allowing for quick and easy measurement of ground current. Choosing the right testing method and instrument depends on the specific application and the level of accuracy required, balancing convenience, cost, and reliability. Regular ground rod testing is an essential part of a comprehensive electrical safety program, helping to prevent electrical hazards and ensure the safe operation of electrical equipment. Remember that soil conditions, moisture content, and the presence of corrosion can affect ground rod resistance, so it's important to consider these factors when interpreting test results. Properly installed and maintained grounding systems are critical for protecting people and equipment from electrical shock and damage, making ground rod testing an important task for electrical professionals. When interpreting the test results from the Amprobe DGC-1000 or any other ground rod tester, it's important to compare the measured resistance value to acceptable limits specified in relevant electrical codes and standards, such as the National Electrical Code, or NEC. The NEC provides guidance on acceptable ground resistance values and the requirements for grounding systems. Typically, a ground resistance of 25 ohms or less is considered acceptable by the NEC for a single ground rod. However, local regulations or specific application requirements may dictate lower resistance values. If the measured ground resistance exceeds the acceptable limit, it indicates a problem with the grounding system that needs to be addressed. Possible causes of high ground resistance include corrosion of the ground rod, poor connection between the ground rod and the grounding conductor, dry or sandy soil conditions, or a broken or damaged ground rod. To improve ground resistance, several measures can be taken, such as driving additional ground rods and bonding them together, treating the soil around the ground rod with ground enhancement materials, or replacing corroded or damaged ground rods and connectors. It's also important to ensure that all connections in the grounding system are clean, tight, and corrosion-free. Regular inspection and maintenance of the grounding system can help prevent problems and ensure that it continues to provide effective protection. In addition to measuring ground resistance, it's also important to inspect the physical condition of the ground rod and its connections to ensure that they are in good working order. Look for signs of corrosion, damage, or loose connections, and address any issues promptly. Proper grounding is essential for electrical safety and the reliable operation of electrical equipment. By understanding the principles of ground rod testing and using appropriate testing methods and instruments, electrical professionals can ensure that grounding systems are properly installed and maintained, protecting people and property from electrical hazards. The Amprobe DGC-1000 is a valuable tool for ground rod testing, but it's important to be aware of its limitations and to use it correctly. For highly sensitive applications or for testing very low resistance ground rods, consider using additional testing methods or instruments as needed. Always follow proper safety procedures when working with electrical equipment, and consult with a qualified electrical professional if you have any questions or concerns. Grounding systems play a critical role in electrical safety by providing a low impedance path for fault current to flow back to the source, tripping circuit breakers or fuses and preventing electrical shock hazards. Effective grounding helps to minimize voltage differences between conductive surfaces, reducing the risk of electric shock to personnel who may come into contact with them. Grounding also helps to protect sensitive electronic equipment from damage caused by voltage surges and transients. A well-designed and properly maintained grounding system is an essential component of any electrical installation, ensuring the safety of people and equipment. Regular testing of ground rods and other grounding components is necessary to verify their effectiveness and to identify any potential problems that may need to be addressed. The Amprobe DGC-1000 provides a convenient and reliable means of testing ground rod resistance, but it's important to understand its limitations and to use it in accordance with the manufacturer's instructions. For critical applications or where greater accuracy is required, consider using alternative testing methods such as the fall of potential method. Remember that soil conditions, moisture content, and the presence of corrosion can all affect ground resistance, so it's important to consider these factors when interpreting test results. Proper grounding is a fundamental aspect of electrical safety and should never be overlooked. By understanding the principles of grounding and using appropriate testing methods, electrical professionals can ensure that grounding systems are properly installed and maintained, protecting people and property from electrical hazards. Always consult with a qualified electrical professional if you have any questions or concerns about grounding or electrical safety. When performing ground rod testing, it's important to document the test results, including the date of the test, the location of the ground rod, the measured resistance value, and any other relevant observations. This documentation can be used to track the performance of the grounding system over time and to identify any trends or potential problems. Regular ground rod testing should be performed at intervals recommended by relevant electrical codes and standards, or more frequently if site conditions warrant. Maintaining accurate records of ground rod testing is an important part of a comprehensive electrical safety program. In addition to ground rod testing, it's also important to perform visual inspections of the grounding system to identify any signs of damage, corrosion, or loose connections. Any issues that are identified should be addressed promptly to ensure the continued effectiveness of the grounding system. Grounding systems are an essential part of electrical safety, and regular testing and maintenance are necessary to ensure their continued effectiveness. The Amprobe DGC-1000 is a valuable tool for ground rod testing, but it's important to use it in accordance with the manufacturer's instructions and to understand its limitations. For critical applications or where greater accuracy is required, consider using alternative testing methods such as the fall-of-potential method. Always consult with a qualified electrical professional if you have any questions or concerns about grounding or electrical safety. Ensuring proper grounding is a critical aspect of electrical system design and maintenance. The goal is to provide a low-impedance path for fault currents to return to the source, allowing protective devices like circuit breakers to quickly trip and energize the circuit. This minimizes the risk of electrical shock and equipment damage. Several factors influence the effectiveness of a grounding system. These include the soil resistivity, the depth and diameter of the ground rods, the number of ground rods used, and the quality of the connections. Soil resistivity varies depending on the type of soil, its moisture content, and its temperature. Lower soil resistivity results in lower ground resistance, which is desirable. Ground rods should be driven deep enough to reach moist soil, as this helps to reduce ground resistance. Multiple ground rods bonded together can also help to lower ground resistance. All connections in the grounding system should be made with corrosion-resistant materials and should be properly tightened to ensure a good electrical connection. Regular inspection and maintenance of the grounding system are essential to ensure its continued effectiveness. This includes visual inspection of ground rods and connections, as well as periodic testing of ground resistance. Any signs of corrosion or damage should be addressed promptly. The Amprobe DGC-1000 is a useful tool for measuring ground resistance, but it's important to understand its limitations. It's a loop tester, meaning it measures the resistance of the entire ground loop, including the ground rod, the grounding conductor, and the earth return path. This can be useful for identifying problems in the grounding system, but it doesn't provide a direct measurement of the ground rod resistance itself. For a more accurate measurement of ground rod resistance, the fall-of-potential method is recommended. This method involves driving two auxiliary ground rods into the earth in a line away from the ground rod being tested. A current is injected into the earth through one auxiliary rod, and the voltage drop between the ground rod being tested and the other auxiliary rod is measured. The ground resistance is then calculated using Ohm's law. The fall-of-potential method requires specialized equipment and expertise, but it provides a more accurate and reliable measurement of ground rod resistance than the Amprobe DGC-1000. Regardless of the method used, it's important to compare the measured ground resistance to the acceptable limits specified in relevant electrical codes and standards. If the ground resistance exceeds the acceptable limit, corrective action should be taken to improve the grounding system. Proper grounding is essential for electrical safety and equipment protection. By understanding the principles of grounding and performing regular testing and maintenance, electrical professionals can ensure that grounding systems are properly installed and maintained, protecting people and property from electrical hazards. Remember to consult with a qualified electrical professional if you have any questions or concerns about grounding or electrical safety. The Amprobe DGC-1000 is a convenient tool for initial ground resistance checks, but it's crucial to understand its limitations and when more sophisticated testing methods are required.